Dear friends, today my topic is capacitance of the parallel plate capacitor with the conducting slab. This is positive, this positive plate, negative plate of the capacitor, and area of the plate is like of this shape. I mean, it is having some area which is A, because it is a this line, it is a section view. So area of each plate, okay, is capital A. Now the capacitor is charged by some external means. So this plate is acquiring plus Q charge. It acquires plus Q charge. This plate acquires minus Q charge. Okay. Now you know very well the formula of the parallel plate capacitor, because distance between the two plates is small d. So the formula becomes C is equals to epsilon naught, which is the medium. Okay, free space mean there is no medium, it is a free space. There are two plates only, and between the two plates there is a free space. And then A by D. This is the formula of parallel plate capacitor. Okay. Now then, what happened? Now then, we have inserted a conducting slab in between the parallel plate capacitor. The thickness of the slab is T. This is a conducting slab. Conductor having millions, trillions, uncountable free electrons. So because conducting slab is in between the charged capacitor and positive charge is over this plate, negative charge is over this plate, what happened? The electron of the conducting slab, they will start appearing on this face and would the left behind the positive. Okay. So what happened inside the conducting slab? Electrons, they experience attractive force because of this positive plate. So they will start accumulating over this face of the conducting slab and left behind the positive. Now you'll think how many electrons they will accumulate here. It depends how much charge is here. So it is that if the external field, positive to negative, external field is E naught and external field is positive to negative, what happens? Another field develops inside the conducting slab, positive to negative, and the magnitude of the charge which accumulates here, it is of that magnitude so that the internal field also will be of the same magnitude, E naught, but opposite in direction, like this. So what happens inside? Now inside there are two fields. One is the external field, okay, which is because of the capacitor. Second is the internal field, positive to negative, because it is a conducting slab. Okay, and what is the total? Total, the field becomes 0. So there is no field now inside the conducting slab. And you can also say like this: the field will be now only in the free space where there is no conducting slab. The electric field will now in the rest of the space where there is no conducting slab. Mean positive to negative, like this, positive to negative. What are the negative charges? They are the electrons. They appeared on the upper face. And positive is here. Okay. And positive to negative, now the field will be E naught. And again positive to negative, the field will be E naught. The field remains only in the empty space where there is no conducting slab. In the conducting slab, the field becomes 0. Right? Now relation between potential, electrical field and distance. Electrical field is potential over distance. So field is E naught. Electrical field is E naught. E naught is potential over distance. Now you know what is the distance where the field is now present. It is not in the D space, because in a T space there is no field. The field is only between D and T. So this is the expression of, so potential becomes E naught into D minus T. Now what is E naught? E naught is, by Gauss theorem, it is sigma upon epsilon naught. What is sigma? Surface charge density, which is Q by A. So Q by A epsilon naught D minus T. Okay, this is the value of the potential. Now you know the formula of the capacitance. This is the capacitance when there was no conducting slab. Now when there is a conducting slab, the capacitance becomes C. C is equals to Q by V. Substituting this value of V here, so Q divided by Q upon A epsilon naught D minus T. Now Q and Q cancels out. What becomes then? It is epsilon naught A upon D minus T. So this is the value of the capacitance. When there was no conducting slab, the capacitance was C naught. When there is a conducting slab, then the capacitance is epsilon naught A upon D minus T. Now just comparing the two, C naught is epsilon naught A by D and C is epsilon naught A upon D minus T. So dividing the two, so this cancels, or you can say C naught upon C is D minus T upon D. Okay, or you can say C becomes now C naught D upon D minus T. Right? Now D may be taken as common from here. C is equals to C naught D upon D common 1 minus T upon D. So this DD cancels. So C becomes C naught upon 1 minus T upon D. What it implies? Because, now this expression shows that C will be greater than C naught, because denominator is less as compared to numerator. D minus T is less as compared to D. So C becomes greater than C naught. And similarly here. So C is greater than C naught. Capacitance always increases when you put a conducting slab. Like this is a capacitor. You put a conducting slab in between of thickness T. What happens? Capacitance increases. How much is increased? It depends upon the thickness of the conducting slab. If T is equals to D, what will happen? If T is equals to D, so D upon D is 1, 1 minus 1 is 0. So in that case, C becomes infinity. If T becomes D, mean if you fill the whole space with some conducting material, then capacitance tends to infinity. Okay. Thank you.